Okay, so what we're going to do is we're simply going to check this magic eye tube in the tube tester and see how it's working. And the way you test these in the tube tester is pretty much like any other tube, except there's two settings. In one setting the eye should be open, and the other setting the eye should be closed. And we will see what really happens. So 6G5, found it here in my list. So let's set up the tube tester here. 6G5 be 6.3 JR 5403 with a 0. 5403 with a 0. No, there's no bias, there's no English on it. So we're not reading this this meter at all. In this test, we're simply looking at the eye. The first test, the eye should be open. Okay, so this is a 6-pin tube. 6-pin tube. Right there. Okay, so in this position we should see it open. I remember this is a very, very dull one. I'm not seeing anything in it here eye-wise. Let's turn down some lights. Let's turn down all the lights. Doesn't look right at all. All we're seeing on it, and you're not seeing much of anything from there, so let me take you up and take a closer look here. Okay, now, interesting. Looks a little different in the camera. But when I look at it with my eye, all I'm seeing is a reflection of the element glowing below. And see in the center, there's a dark disc. That's a metal. Well, it's kind of like a reflector, deflector, or something like that. So you can't see through it. But if you could, there'd be a hole underneath there. You could look kind of down into the tube. You'd see the heater. So some of the heater light is reflecting up off the part that's supposed to be green. That's crummy though. Let's try the other setting now and see what happens here. I think all we're finding out is that this tube's got no oomph. Okay, the other setting is we just flip switch number 3 over to 2. A little dark in here. Switch number 3. 3. Is that correct? Over to 2. Yeah. Absolutely nothing happening. Huh. Oh, I'm supposed to push P4 for crying out loud. Okay, hold on. Put on the brakes, everybody. Jimmy's not doing it right. Okay, so we're on 4. Let's go to 2. Let me double check these settings now. Yeah. Oh, 0. So it should be, oh my gosh, I messed this all up. I've messed it all up. Let's get it right. 5403. 5403. With a 0 at the end. Okay, so now we're all set. Eye open. Push the button this time, Jim. Let's see what happens. Hey, look at that. That's a little better. Okay. Hey, you know what? This tube's checking good. Let me just flip it the other way now to eye closed. Oh my gosh, this tube is good. How come it's not good in the radio? Okay, so watch. This is eye closed. See, the whole thing is one big green circle. And this is I open. And you can see there's a big gap in it now. And although it looks very bright on the camera, it's reasonably bright in my eyes. Well, there's nothing wrong with this tube. Okay, I know what the next suspicious character is. The next suspicious character in this process of getting one of these magic eyes to go is that resistor we saw sticking out of the back of the connector. That's got to be our next goal here, is to verify that that resistor is good. Because for some reason they tend to be the thing that fails. Interestingly enough, the magic eye appears nowhere on my schematic except for a statement right here. 2 grid of 6G5. That's all it says. It doesn't really show it anywhere. So, unless I just haven't spotted it in here yet. So our problem is pretty certain to be, well, not pretty certain to be. The next most likely problem is this little resistor here. So we'll take a little bit of a closer look at it. Unfortunately, we have to pull this apart to oh, I can see a little locking tabs. So you push this piece in and there's little tiny bumps along the edge here that lock it. It should be pretty easy to get it out past there. Maybe we can test this resistor though without doing that. Usually the resistor runs between 2 pins. And so I think what's going on here is, you can see this wire here, pointing with a drill bit. Hey, how about a better drill bit to point with? So you can see this bare wire heading down, it connects to one of the terminals. That wire comes up, connects to the top of the resistor. The resistor heads in there, no doubt connecting to a terminal. I would say it's these two here. Let's put the ohmmeter in there and see what happens. Bit of a blind shot here, but now what are those resistors normally? I think they're just a couple thousand ohms. I don't think they're much more than that. I'm going to use a clip lead here. Okay, should get a 0. There we go. Okay, so I think when I come down here, that's that wire that goes to the other side of the resistor. And effectively, I'm just measuring the resistance of a piece of wire, which is 0. The next pin over looks to me like the one that contains the resistor, and I'm on the 200K, and it's not showing up at all. So I'm probably on the wrong pin here. Let's try this one. Well, there's something. I'm getting a negative reading on my meter. What's that tell you? So I interpret the negative reading on my ohm meter as meaning there's voltage here interfering with the reading. .6 volts from some capacitor somewhere. Well, I don't think this resistor is going to be different from radio to radio to radio. It's going to be very, very similar in size. So we can figure out typically what that is. So far, the impression I get is it's open circuit or something like that. That's not so good. Let's take this apart. We're going to have to anyway, because I'm pretty sure we got to properly test that resistor. Yeah, right. Oh, there's a whole bunch of locking tabs around here. The whole thing is one continuous. Ugh. How are you supposed to get that out without wrecking it? I don't know if you could hear that beeping right now. That's my coffee maker calling to me. Holy smokes. This is going to be damaged for sure if I push it. You know, the best way to push it from the behind and just let the cardboard bend a bit on the way out. It wouldn't be just like it got bent on the way in. The magic eye is a big time feature here. We got to get it going. Wow, that's just solid as can be. Am I missing something? Is there something more that comes apart? No, this looks like a totally solid piece here. Guess we don't need the clip lead on there anymore. Lucky these wires are in good shape. They can take all this handling. You know, if I can just get this started in one spot, it'll kind of lift up all the way around, if you know what I mean. I think that's metal. Nah, it wouldn't be metal. There's no way that would be metal. Just get it up past one or two of those little locky bumps. I think you'll almost fall it at that point. There we go. Oh, that didn't reveal what I thought the whole thing was coming out. Oh man, look at that schmozzle. Holy smokes, they push up through. Okay. Well, let's push the resistor one up through. It's an ugly soldered mess in here. Okay, the one with the resistor doesn't want to go anywhere. The other ones are leaping out. Okay, I know which one it is from wiggling it. It's this one here. I can't get a grip with these. good grip. I think what I gotta do is I gotta unsolder this. And apparently push that resistor and the lug right out. Apparently that's what I gotta do. Yeah. Okay. Hey, there's the sound of my furnace coming on. What's going on? It's snowing outside today. Yeah, it's snowing right now. We have snow on the ground again. Holy smokes, it's -1 degrees. So the winter's sort of come back here to the Toronto area. Just for a day or two. Okay, so what I'm going to do, I'm just going to snip this. Oh, should I do that? What if this resistor's good? Let's do another test on the resistor. Oh my gosh. Huh. Oh, you know what? Sometimes the stuff you see when you look close. Let me get this really close here. It's really close. Now, I'm going to wiggle this. You watch carefully. I'm just trying to get the focus perfect here. Okay, I'm wiggling. Now, if you aren't seeing something curious, I'll point where to look. Okay, look right. Oh, jeez. Here. Right there. Keep your eye right on that spot there. How you looking? Can you see that the wire is popping up and down there? That's this wire here. Failed connection. Would that be the whole cause of the problem here? We don't need to do any more. You know what? We need to solder that wire and test it. That's really the wise thing to do at this point. I'm going to put this down somehow. Okay, let's just give it a shot here. Could this be all it was? I don't know. It's a good chance that wire broke away because of me fiddling around with it. Although, you know, it would have to be in a fairly bad state to begin with. I'm holding my breath here while I do this. Pretty sure that got it. Yeah. Okay, so let's put this back together kind of on a temporary basis. I'm worried about plugging the tube in there without the without that plastic cardboard cover, rather, because when I pull the tube out, the pins are going to come with it. If they don't come far enough, I can get kind of trapped in here with the tube. I'm going to have to run that risk. So I'm going to put the tube in, but not all the way in. Oh, another problem. No, it's not really a problem. Another problem is getting this tube in the right way. In this case, you really have to rely on the tube pin sizes because they're a symmetric arrangement here. Put this in the wrong way. Not with that cover. The cover makes sure that big pins go where big pins are supposed to go. Okay, so there we got it. I think that's in far enough for a test. This would be great if this comes to life. Fantastic. Anybody want to wager odds here? Okay, I give it 20% odds. Now you know what? This is not coming on unless I put in the speaker. Oh boy. Okay, let me go and do that. I'll get this thing set up for a test here. Okay, so we're just about ready to go here. Let's put on the hot chassis warning light. Plug that set in. Okay, the set is switched on, the volume down. Quick safety check here. Things straighten up a little bit. Okay, we're all set. Let's hit the power here. An eye on that tube, which should be pretty green by now, I would think. Here it comes. Oh, you strange radio, you. Let's give it full power here. Hey, something new. Every time I turn the volume up a bit. Oh, how do you like that? Okay, let's pay attention to that magic eye. I don't think there's any magic coming from the magic eye. Well, there it is. Look at that. Come on. Okay, there we go. Yeah. It's a little duller than it was in the tube tester. Well, I think the good news is it works. It's dull. And that might reflect a few other things here about this radio and how the power supply has been manipulated. Yeah, so you can see in regular light, there's no hope of seeing that. You wouldn't know it's even working at all. You have to get into darkness. So and I don't think it's the tube. It's something about the radio now. Let's think about that a little bit here. Let's listen again to it. It's just a mild hum in there, not much. I think we can declare it all done. I think changing that tube with another one, that might make some difference, and maybe another newer tube will operate under the conditions that this one just won't quite make it. But the fact is that the circuitry is working. You can see the AVC action, which I was really excited to see. So I dare say we're done here. Just something kind of curious about how dull these front panel lights are. They're really dull. These two lights here. Maybe they're the wrong type of bulb. Where are they getting their voltage from anyway? There's no transformer in here. Let's take a look at that situation a little bit and see. What did I do with the schematic? Which I had in my, there it is. Schematic here. So here's all the tubes in series. Here's some resistors here. Do you know what? Those aren't resistors. Those are actually the heater elements of this tube. And halfway through it, it has these two bulbs. This is right there, 6.3 volts, points to them. Two 6.3 volt bulbs. So that's the question. What is in there are these 6.3 volt bulbs? And an interesting observation, you know, about how this is done. Now, these bulbs are sitting across one of these elements here. And so what happens when the set is first switched on, you'll see these bulbs get really bright briefly. And so they're taking the shock of current that's flowing through these cold filaments, heading for the filament of the rectifier tube. And some of that current is diverted into these light bulbs. And it just takes the shock down a little bit, the thermal shock on that tube. And then as these guys warm up, the current begins to fall, you'll see these lights come down in brightness. And then, once the whole radio gets operating, these bulbs become brighter again, because they actually have some, I think this is the case anyway, some of the DC current that's flowing through all the tubes in the radio flows through these light bulbs. So that's normally what you should see when you turn on one of these radios. Is these lights get bright, dull, and then they come up again, usually just as the sound is coming on. So what is in here? So this is a 6-8. This is a 44. 6 to 8 volts. That's quite a range, you know. 6 to 8. That's kind of a crazy. This guy doesn't want to come out. There he goes. And he's also a 44. Mazda. Does it even indicate here what kind of light should go in there? Just says 6.3 volt. The most common light in these radios is a 47. 44. I don't have these things memorized by any means, so let's check out. I should have a little chart on my wall here. Maybe on the side of the refrigerator behind me. That'd be a good idea. So we're going to look up bulb number 44. Unable to connect. Pardon me for one moment here while I let my tablet battery wear right down, and just like your telephone, the last thing it does before it quits entirely is it shuts off all the wireless stuff. Then when you start it up, bulb. Oh, what happened to the number 44? Number 44. 6.3 volt, 0.25 amp, so it takes a fairly high current. And but it's a 6.3 volt according to this. Just reading what others are saying about it. So it's kind of strange to say 6 to 8 volts. I mean, every bulb has a rating. Like, let's say a 6 volt rating. It should give you its stated life. In this case, the 8 should give you the stated life. And you can run any light on lower voltage. So it's an 8 volt bulb you can run on 6. I mean, that's not exactly big news, is it? I guess they were trying to suggest, here's a universal bulb, you can stick it in anywhere you want. And sorry if that sounded a little bit rude, but so 47 is a 0.15 amp, so it half the current. Let's put a 47 in there. I think it's going to be a lot brighter. $44, $45, $47. Okay, I should put a brand new and an old one at the same time. Why would we bother doing that? It's hard getting them out. It's hard getting them into this one. There we are. Now, along with being brighter, they will be hotter. There's a bit of a drawback on that. And they may get quite bright when we first turn them on. It'd be interesting to see if they can tolerate this. So we're plugged in, we'll apply the power, switch is on, volume is down, hot chassis light on, here we go. Wow, did you see that? Wasn't that exciting? Now you can see that instantly very bright, and then down, down, down. Now we are on restricted voltage too, so those didn't go as bright as they could have. And now it should start brightening up again as we hear the radio come on. Let's see if this happens. It might be a little tricky to see on the camera. There comes the radio. Well, it didn't seem to get any brighter to me at all. perhaps in this arrangement they don't take any of the plate current through them, but I know there are some cases. So the light bulbs are actually a very clever element in a lot of these radios to protect the heaters from taking thermal shock on turn on. And when these are burned out, then that protection is gone. And there we are. They're also not terribly bright. Hey, let's put it on full power here. That's a little better. How about that magic eye? Did it make any difference? No, of course not. Okay, I think all we got to do now is strap that magic eye back in. And then what's left is that terrible problem with the front here, and a number of ideas about how to deal with that front problem. I'm just going to put it in like that. That's the damaged, falling apart dial. Probably the only practical thing that can be done for the falling apart dial is to tape it from behind and to try to secure it that way. And I'm not sure what else we can do to fix that. And everything we do is, every time we touch that thing, there's a risk of just damaging it even further. So, you know, I'm not happy that it's out of the radio. It's out here in the world with us. And it may not bode well for it. Have to be very, very careful with it. Because as I noticed, the slightest bend, it's going to crack. So that means during storage, transportation, you know, it's living its life here. You might think in the front here it's exposed in some way, but actually it's highly protected while it's in the radio. And so it is true of everything. And when the radio is in its case, it's quite well protected. Okay, now I think I got this in on a... How do you even know? I don't know. I'm going to set it right like that. What I was talking about was how I got this thing twisted from how it really should be. Don't move around. You're supposed to be locked in tight.